Alright, this recording is to help you with lesson 6.05, and I know I'm going to pronounce this wrong because I do it every year. I believe it said de Moivre's theorem, and I apologize if I said it wrong. Alright, but basically what we're going to do is we are going to represent a complex number graphically and then find the trigonometric form of that number. So we have 3 minus 3i. So we're going to take our coordinate plane here, and instead of calling it the xy axis, we're going to refer to it as the real and the imaginary axis. So we have the real axis, which is your x, and your imaginary axis, which is your y. So the first number, we're going to treat this like an ordered pair, 3, negative 3. And notice that the I is there for imaginary, so that refers to your y-axis. So just like a point. If we were to graph this, we'd have to go 3 to the right and then 3 down. We find your point there. And it is just with respect to the origin, so we usually draw a dashed line back to our origin. So that's how we can graph that complex number. Now let's find the trigonometric form. In order to do that, we need an r and a theta. To find r, we are just going to take the square root of a squared plus b squared. And I'm going to call it a and b because usually the standard form is written a plus or minus bi. Okay? So a in this case is positive 3, and b in this case is negative 3. So 3 squared plus negative 3 squared, well that's 9 plus 9, which is 18. We can simplify that square root of 18, 9 times 2. And the square root of 9 is 3. So that's how we can get 3 square root 2 for r. And then to find theta, we're going to treat it kind of like a right triangle here. We're going to take tangent of theta equals b over a. So in this case, negative 3 over 3. Well, that obviously equals negative 1. Now, you have to look to see what quadrant you're working in. Well, what quadrant are we in over here? We're in quadrant 4. So where does tangent equal negative 1 in quadrant 4? Well, tangent equals negative 1 in quadrant 4 at 7 pi over 4. So that is what we're going to get for our theta. And this is important because if you're not working in quadrant 1 or possibly quadrant 2, your calculator is not going to give you this answer. So it is important that we're using our unit circle right now to find these. And then the trigonometric form we know is r times cosine of theta plus I sine of theta. So just plugging those values in, we get 3 square root 2 times cosine of 7 pi over 4 plus I sine of 7 pi over 4. All right, next, let's represent the complex number graphically and find the standard form this time. So now we have this complex number in the trigonometric form, and we want to work backwards to find the standard form. So all we need to do is use our unit circle and then simplify. So let's replace cosine of 150 and sine of 150. Well, cosine of 150 degrees is negative square root 3 over 2. And sine of 150 degrees is 1/2. Okay, let's distribute the 2. When I do that, those cancel. So I get negative square root 3 plus 1i. So there is the standard form. And let's graph that then. So that's technically the point, negative square root 3, 1. So I'd have to move negative square root 3 to the left and up 1. That puts me in quadrant 2 there, which is where 150 degrees is, in quadrant 2. And then we just draw a dashed line back to the origin. All right, let's actually perform the operations, and I'm going to bring you back all the way to logarithmic properties. Remember, when we were multiplying, what did we do with our values there? we added them, and that's what we're going to be thinking of here too. Well, the constants outside we can start by multiplying. So 3 times 4 is 12. But then we're talking about theta. What do we do with the pi over 3 and that pi over 6? Well, because we're multiplying and we want to combine them or condense them, we add. So pi over 3 plus pi over 6, you do need a common denominator of 6 there. So that's 2 pi over 6 plus pi over 6. Altogether, that gives you 3 pi over 6. Reduce that, and we can get pi over 2. So when we perform the operation there, that's how we can get 12 times the cosine of pi over 2 plus I sine of pi over 2. So when you multiply, you add your thetas. When you divide, we subtract our thetas, okay? So we're still dividing those numbers out front. So 12 divided by 3 is 4. But now let's subtract the thetas. 52 minus 110 is our negative 58. So that's how we get our answer right here. Okay. And the last thing, which I think is probably the most complicated, is actually using de Moivre's theorem here to find the indicated power. So what happens if you have a complex number, but you have an exponent now? So it's just some type of power other than 1. We're not familiar with how to do that, but we can do that fairly easily. Okay? What we would do is first we want to write this in the trigonometric form. Okay, so we need to find out what r and theta are. So let's start with r. R is the square root of 1 squared plus 1 squared, because that's a and b respectively, right? So that's the square root of 2. And then we have tangent theta equals b over a, so 1 over 1. And because we are dealing with quadrant 1 here, because the point 1, 1 falls in quadrant 1, tangent equals positive 1 at pi over 4. So that is how we started out here in the trigonometric form. So we get the square root of 2 times cosine of pi over 4 plus I sine of pi over 4. And all of this is to the 5th power. So let's actually apply that 5th power now. Well, obviously it's going to come out to the square root of 2. And now how we can apply that to the cosine and sine is we're going to multiply by that exponent. So 5 times pi over 4. And 5 times pi over 4 is 5 pi over 4. So when we're applying it to cosine and sine, you multiply by that exponent. Okay? And now all that's left to do is simplify. So the square root of 2 to the 5th power. You can use your calculator here, or you can probably do this one in your head, kind of. So we're multiplying this together 5 times. Finding a pattern always works too. So 2 times 2 equals 4 square root 2. So that's how we get that. And then we're using our unit circle. What does cosine of 5 pi over 4 equal? What does sine of 5 pi over 4 equal? And we get these values respectively. Now you can also notice that you might not get a value for your theta that's on the unit circle. If that's the case, you'll have to subtract 2 pi until you can get a value that's on your unit circle. Okay? So you might have to subtract 2 pi until you get a value on your unit circle here. Okay. When we distribute this, let's see what we end up with. 4 times 2 is 8 over 2 minus 4 over 2. 4 times 2 is 8, sorry. So we get negative 4 minus 4i once we distribute to 4 square root 2.